Yes. Hello everyone, this is D. Chinnagokari. So, welcome to my channel. In the last lectures, I explained about introduction of atomic structure, what are the modern theory and what is the Dalton theory and what are the contradictions between modern theory and Dalton theory. Then after, I discussed about discovery of subatomic particles like discovery of protons, discovery of electron, discovery of neutron by using the discharge relative, and also I explained about some atomic models like Thomson atomic model, Rutherford atomic model, and in this lecture I am going to explain about nature of light. In previous lecture I explained about Rutherford atomic model. So here what is Rutherford atomic model? Rutherford atomic model, it is nothing but here atoms, according to Rutherford, atoms are having spherical shape and the total positive charge present in the center of the atom, that is called nucleus, and the electrons revolve around the nucleus in a circular orbits. These circular orbits are called paths or shells. The circular paths are called shells or orbits. So here he explained the stability of this atom by using two type of forces. So that is one is Coulombic forces. Coulombic force. The Coulombic forces are nothing but the attraction force between the positive charge and negative charge, or attraction between the electron and proton. So that these Coulombic force bring the two particles close, but what Rutherford is saying, it is not staying in a fixed position but it is rotating continuously. So when it rotates continuously, another type of forces are also arises, that is centrifugal force. Centrifugal force. So this centrifugal force keeps away this positive charge and negative charge. It is simply when we rotate a rock by to attaching a thread by holding with our hand like this. So what happens if we rotate continuously, even though how much strongly if you want to pull that rock towards you, but it is not comes towards you. So just like take a thread and tie to it, and if you rotate like this, so what happens, it rotates continuously when how much you are rotating, but whenever you want to pull this inside, it is not going to come, it is rotates continuously. So that type of forces is called centrifugal force. See, when you leave it simply, it moves away from you. So like that, when the electrons rotate around the nucleus, so centrifugal forces are there. These centrifugal forces, what they want to do, they keep the electron away from this positive charge, and whereas Coulombic forces are bring the these two particles close together. Here both centrifugal force and Coulombic forces are equal according to this Rutherford. That's why they are not falling in the nucleus. That's why it is not staying in a particular position, it is continuously rotates. So in this way he explained the stability of atom. But here another scientist, James Maxwell, he proposed a theory, that is electromagnetic theory. Electromagnetic theory. According to this theory, when a charged body rotates around another charged body, it emits the radiation, it loses its energy in the form of radiation. So why it loses its energy in the form of radiation according to James Maxwell? Here when this electron want to rotate around this nucleus, so it loses its energy continuously. Why? Because when it is going to rotate in a circular path, it continuously accelerates. So continuously accelerates due to change in direction. in one place, in this it is having this direction, in this position it is having this direction, in this position it is having direction. Likewise, it should change its direction continuously when it rotates around another charged body. So according to James Maxwell electromagnetic theory of radiation, when a charged body rotates around another charged body, it continuously accelerates. Why? Because due to change in the direction, it continuously accelerates. When it accelerates continuously, what happens? It is going to lose its energy in the form of radiation. In the form of radiation. So it is not going to revolve in a circular path when it loses its energy, and it is going to take a spiral path. It is going to take a spiral path. It is going to take a spiral path, and it ultimately it is going to fall in the nucleus, and the atom will be collapses. So when the electron and proton are get direct contact, they are going to cancel out, and there will be no electron and no proton. But still we can find the electron and proton inside the atom. So there are some failures are also there in the Rutherford atomic model. The first failure is it is unable to, what are the demerits of Rutherford atomic model. What are the demerits of Rutherford atomic model? So they are, first one, it is not explained that it failed to explain the stability of atom. It failed to explain the stability of atom, and also it failed to explain the spectrum of atoms with special reference to hydrogen. It failed to explain spectrum. It failed to explain spectrum with special reference to hydrogen. Here, what is the spectrum? We will discuss in the next lectures. Okay. So here, for a brief idea, so spectrum is nothing but it is a photograph of the radiation. So when, according to this, when it lose energy continuously, it should give continuous spectrum like this. But when you observe practically, there is no continuous spectrum. You are getting discontinuous spectrum. You are getting discontinuous spectrum in the experimentally. But when it lose energy continuously, we should get a continuous spectrum. But practically we are getting discontinuous spectrum. I will discuss about what is the continuous spectrum, what is the discontinuous spectrum in the next lectures. So here, first of all, we need to understand about radiation. First we need to study about the radiation, so to understand further atomic models. So let us start about radiation. Now let us learn about radiation. Here, radiation is nothing but it is a light. So now let us discuss about nature of light. Nature of light. Nature of light. So here, nature of light, here it is nothing but how it is moving from one place to another place. So here we have two theories about the nature of light. They are, the first one is corpuscular theory. Corpuscular theory was proposed by the scientist Newton, and wave theory. So here, wave theory was proposed by the scientist Huygens. So here corpuscular theory can successfully explain the reflection and refraction. So it can explain, or first of all, what is corpuscular theory? It's corpuscular theory is nothing but according to this theory, so light travels from one place to another place in the form of small packets, small energy packets, small energy packets. So these small energy packets are called corpuscle. The small energy packet is called corpuscle, and this theory can successfully explain the reflection and refraction. This theory can successfully explain reflection and refraction. It can successfully explain the reflection and refraction. So we already know reflection is nothing but when a light ray falls on a object, it again enters into the same medium. By bouncing back, again it enters into the same medium. That is called reflection. And whereas refraction is when a light ray travels from one medium to another medium. For example, let us consider this is the one medium air, it is, let us consider it as a water. So when a light ray travels from one medium to another medium, it is not going to travel in a straight line. So we already know that light travels in a straight line because it can forms the images. So here light is not going to travel in a straight line, but it is bending from the medium. It bends and travels. This phenomenon is called refraction. But it failed to explain the phenomena like diffraction. Failed to explain, this theory is failed to explain diffraction and first of all diffraction. Diffraction is nothing but when a light travels in the solid object, any other object here, it travels through an obstacle. It travels through the obstacle. It is nothing but it is a point or it is a solid particle. Means when a light ray travels in the on any other medium like a solid medium, it is not going to reflect or refract, but it travels through an obstacle. This process is called what? Diffraction. And also it failed to explain the interference. It failed to explain the interference. Here, what is interference? Interference means combination of light waves. When the two light waves are combining, they are going to overlapping in two types. That is positive overlapping and negative overlapping. So here, sorry, here some lizard is fell. So here interference, let us consider these are the wave 1 and this is the wave 2 and this is the resultant wave. This is called positive interference and positive interference and negative interference. Let us consider this is the wave 1 and this is the wave 2 and resultant wave. So resultant wave is like this, means the wave size is decreasing. So this process is nothing but negative interference, negative interference. This is the positive interference. So these phenomena is successfully explained by the using wave theory of light. It can also explain the reflection and refraction. It can also explain the reflection, refraction, and also diffraction, and also dispersion. Here dispersion means when you pass a light ray through a prism, it is going to divide into 7 colors. When you pass a white light through a prism, it is going to divide into 7 colors. This phenomenon is called dispersion and also interference, and also it explains the interference. And this phenomenon can means this corpuscular theory can successfully explain the reflection and refraction, but failed to explain diffraction, interference, and dispersion. It failed to explain the dispersion process. So after the wave theory, this corpuscular theory lose its. So this wave theory, this corpuscular theory can successfully explain the reflection, refraction, but it is failed to explain diffraction, interference, dispersion. Wave theory can also explain the reflection, refraction, diffraction, and dispersion, and also interference. But wave theory is also failed to explain. It failed to explain wave theory. This wave theory failed to explain black body radiation, and it failed to explain photoelectric effect. So but we can explain this black body radiation and photoelectric effect by using the combination of this corpuscular theory and wave theory, and finally there is an agreement between the corpuscular theory and wave theory. So that they said that the light is having dual nature. So light is having dual nature. So which means light can have the corpuscular nature, means particle nature, and also it is having the wave nature. So when the light interacts with matter, it is having particle nature, and when it propagates, it is having wave nature. When it is propagating means what here? When it is moving from one place to another place, that is called what? Propagating. So now let us discuss the wave theory of light. Why? Because this is one of the important theory, wave theory of light. First let us discuss about wave theory of light, the wave nature of light. Yes. So wave theory of light, wave theory of light. So according to this wave theory of light, light first of all, wave theory of light was proposed by, we already know, it was proposed by Huygens. So after the proposition of this wave theory of light, corpuscular theory lost its nature. So according to Huygens, light travels in the form of wave, means light propagates in the form of wave. So when it travels from one place to another place, it travels in the form of wave, right? For example, let us consider this is the origin of the light or the source of light, and from the source of light it is traveling like this. So first of all, what is a wave? Wave is nothing but a disturbance in the medium. Wave is nothing but is a disturbance in the medium. For example, when you drop a rock in the still pond, there also you can observe water waves. It's nothing but disturbance in the medium. So wave, how we can define the wave? That is disturbance in the medium is called what? Wave. So here, according to the Huygens, light also travels in the form of wave. So but James Maxwell proposed that, James Maxwell, according to James Maxwell, when light travels, or when light propagates, alternating electric and magnetic fields are generates, and they propagate along with the light wave. They are propagate along with light, which means, see here, when this is the, let us consider this is the light ray. So this is the light ray traveling from this position to this position by making the waves, and here one electric field generates. This electric field is, let us consider this is the electric field, and this also travels in the form of wave along with the light ray, and another magnetic field also generates. So this is also propagates along with the light ray. So this is the magnetic field. So these are the perpendicular to the light wave, and also they are mutually perpendicular to each other, and they are traveling along with the light ray. That's why this light is also called electromagnetic radiation. Light is also called electromagnetic radiation. In short, it is called EMR. EMR means electromagnetic radiation. Here, why the light is called electromagnetic radiation? Why? Because when a light travels from one place to another place, alternating electric field and magnetic fields are generated, and they travels along with the light wave, which means the light wave is associated with the electric field as well as magnetic field. That's why this is called electromagnetic radiation. Here, both electric field and magnetic field are perpendicular to the path of the light, and also they are perpendicular to each other. See, simply we can explain this by using these objects. So it is not possible to represent on the 2D board. So now let us see here. Let us consider the duster as the light wave. So it is making the waves and it is propagating from this source. And here alternating electric field and magnetic fields are generating. So let us consider this black marker as a electric field and this is the magnetic field. This alternating electric field and magnetic field are generated. So how they are? They are perpendicular to each other. Perpendicular to means 90-degree angle, and here also it is, this electric field is also perpendicular to this the path of the light, and the magnetic field also is perpendicular to the path of the light, but they are traveling along with the light wave like this with these motions. And also this magnetic field also travels along with the light wave by doing this type of motions. So that's why this is called electromagnetic radiation, right? Simply we can show like this. This is the electric field, this is the electric field, and this is the magnetic field. This is the magnetic, this is the magnetic field. So like this is about wave, nature of light. So now let us discuss the wave parameters, means how we can describe the wave. So by using the some parameters we can describe the wave. They are called wave parameters. So what are the wave parameters here? There are mainly 4 wave parameters are there, like wavelength, wave parameters, wave parameters. What are the wave parameters? Wave parameters is nothing but which are used to describe a wave. They are called what? Wave parameters. There are several wave parameters are there. In that first one, that is wavelength. Wavelength. Here what is the wavelength? So the wavelength indicates the symbol lambda, inverted y wheel right here. So that is indicated with lambda. So what is the wavelength here? So now first of all let us see. We already know light travels in the form of waves from one place to another place like this. So this position is called, the peak position in the wave, it is called crest, and the depth position in the wave it is called trough. So here what is the wavelength here? The distance between two successive crests. The distance between two successive crests is called wavelength lambda, or the distance between two successive troughs, it is also called wavelength lambda, or the distance between the two successive equal points. So here it is the descending position. Here also we are taking the descending, next to descending position. So this is what, this is also called wavelength. So what is the wavelength definition? Wavelength it is nothing but the distance between two successive crests, or the distance between two troughs, or the distance between the two successive equal points. The distance between two crests, two successive crests, two successive crest, or two successive trough, or two successive equal points. Two successive equal points, that is called wavelength. So the wavelength indicates the symbol lambda. What are the units? Units of wavelength here, simply that it is the distance, simply the distance units are only the units of wavelength, that is meters, centimeters, nanometers, picometers, Armstrongs. So here we already know what is the relation between them. 1 meter is equal to 10 to the power of 2 or 10 square centimeters. that is equal to 10 to the power of 9 nanometers, that is equal to 10 to the power of 10 Armstrongs, that is equal to 10 to the power of 12 picometers. So this relation we use in the numerical calculations, right? Next wave parameter is frequency. So this is the first wave parameter. Next wave parameter is, that is frequency. Frequency. So here what is frequency? Frequency is nothing but, frequency indicated with symbol nu, like we will write, it is pronounced as nu, nu. So what is frequency? Frequency is nothing but, so the number of waves passed through a point, the number of waves passed through a point in a unit time, the number of waves passed through a point in a unit time. For example, let us set this point per second. So the number of waves passed through a particular point in a second, that is called what? Frequency. So frequency, so how we can define the frequency? The number of waves passed through a point, the number of waves passed through a point, passed through a point in 1 second, or in 1 unit, in unit time, in 1 second, in 1 second, that is called what? Frequency. So here frequency, what are the units for the frequency? So units for the frequency are per second, CPS. So what is the CPS here? CPS means cycles per second, cycles per second, and heads also, heads. So simply you write HZ, that is nothing but heads. Here per second is equal to 1 CPS, that is equal to heads, right? So this is the relation between the units of the frequency, and sometimes we represent 1 MHz, 1 megahertz, that is equal to 10 to the power of 6 hertz, that is called megahertz, or KHZ, that is 10 to the 10 cube hertz is called KHZ. So this is about the frequency. Now the relation between the wavelength and frequency. So what is the relation between wavelength and frequency? So it's clear, wavelength and frequency. Now let us discuss about the relation between wavelength and frequency. What is the relation between wavelength and frequency? Wavelength and frequency. So that is so here wavelength, frequency is inversely proportional to wavelength. So means frequency increases, wavelength decreases. So to remove this proportionality, we are going to keep a constant, that is equal to nu is equal to c by lambda. Here we already know nu is the frequency, lambda is the wavelength, and c is a constant, velocity constant, or speed constant, or light velocity, or sometime like that we can take. C is the velocity of light. So here, so it is a constant, the velocity of light is a constant in the vacuum. In the vacuum, all type of electromagnetic radiations can travel with the same velocity, that is c is equal to 3.3 into 10 to the power of 5 kilometers per second, which means per second it is traveling 3 into 10 to the power of 5 kilometers. 3 lakh kilometers it can travel per second, or 3 into 10 to the power of 8 meters per second, or 3 into 10 to the power of 10 centimeters per second. So this is the velocity of light. So it can travel with this much speed. So here what we can say, the velocity of light is always constant, So it is independent on the frequency and wavelength. So here the product of velocity and the product of frequency and wavelength is equal to velocity of light, which means nu into lambda is equal to constant. Nu into lambda is equal to constant. Next, another wave parameter, that is, let us discuss one more wave parameter, that is amplitude, or before the amplitude we have wave number. Wave number that is the number of wave number indicated with the symbol nu bar. So how to read nu bar? So what is wave number here? So nu bar, the number of wavelengths present in a unit length, or simply the number of waves present in the unit length. See, for example, we are taking this is the unit length. So here we are going to count the number of waves, so that this number is called what? Wave number. So what is the definition of wave number here? The number of waves present in the unit length. The number of waves present in the unit length, that is called wave number, or simply reciprocal of wavelength. Reciprocal of wavelength is called wave number. Reciprocal of wavelength is called wave number. So wave number nu bar is equal to 1 by lambda. Nu bar is equal to 1 by lambda. So we already know nu is equal to c by lambda. So in the place of lambda we can substitute the nu bar here, so that nu is equal to c by lambda. What is lambda value here? 1 by lambda is equal to, here it is 1 by lambda, that is c nu bar. So nu is equal to c nu bar. This is also one relation we use to calculate the numerical values. And what are the units? Units of wave number of units are meter inverse, per meter, per centimeter, per nanometer, per angstrom, etc. So these are the units of wave number. And another wave parameter, that is amplitude. So here what is amplitude? So amplitude is nothing but the height of the crust or the depth of the trough. This is called what? Amplitude. So this amplitude indicated with A. So the height of the crust or the depth of the trough is called amplitude. So here amplitude gives information about brightness of the wave or brightness of the light. So here amplitude increases, brightness is also increases. So here what are the units of amplitude? So height units, that is nothing but meters, centimeters, nanometers, etc. These are the units of amplitude. Amplitude is nothing but brightness of the light. Brightness of light, or the height of the crust. Height of crust or depth of trough. Depth of the trough is called what? Wave amplitude. So it gives information about the brightness of the light. So this is about wave parameters. In the next video I am going to solve some numericals, so which are given the NCERT and also which are given in the previous year of IIT JEE mains and also NEET questions. So you can comment on this video whatever the wherever you can not understanding, and I can give reply for you also. And if you like this video, please give it a thumbs up, means like symbol you can press. Thank you.